In this video, I will discuss the concept related to the margin of error, especially when estimating the population mean mu. When we estimate the population mean mu using an interval, then we need to know how to calculate the margin of error. So in this video, our main focus is how to calculate the margin of error when estimating the population mean mu. Now the margin of error, ME, is given by this formula, Z value times SE. We already know what is SE. This is the standard error of the sampling distribution of the sample mean. And Z value is a value that you can get from your book or from your TI calculator using this command inverse normal of 1 minus alpha over 2. Now, alpha is equal to 1 minus confidence level. Most of the times, the confidence level is given in the problem, or this is sometimes called the confidence coefficient. And you can use this relationship confidence level or confidence coefficient is equal to 1 minus alpha, or you can also use alpha equals 1 minus confidence level or confidence coefficient. And the confidence coefficient, the 1 minus alpha, is the probability that a confidence interval will contain the estimated parameter, for example, mu. And if the confidence level is not provided in a problem, you have to assume that it is 95%. Now let's take a look at an example of how to determine the Z value. So here's an example one. Given the confidence level of 90%, what is the value of alpha? And second question, what is the Z value? So here's the answer. We know alpha is equal to 1 minus confidence level or confidence coefficient. So the confidence level is 90%. We're going to convert this number into a decimal number. So 90% is equal to zero point 0.9. So alpha is 1 minus zero point 0.9, or alpha equals 0.10. So that's the answer for the alpha. Now for the Z value, we will use inverse normal 1 minus 0 0.10. So this is the alpha over 2. And 0.10 over 2 is 0.05. So 1 minus 0.05 is equal to 0.95. So this will be the number that we will be using, inverse normal 0.95. So let me show you how to find this value. So in our calculator, we will use secant function distribution and select the third option, inverse normal. Press enter and then type in the number 0.95. So inverse normal 0.95, the value of Z is 1.64. Let's try another example. Here is our second example. Given the confidence level of 99%, what is the value of alpha and what is the Z value? So for the alpha, our formula is alpha equals 1 minus confidence level, and confidence level is 99% or 0.99. So alpha is 1 minus 0.99, or alpha is equal to 0.01. Now for the Z value, we will use inverse normal of 1 minus alpha over 2, and our alpha is 0.01 divided by 2 is 0.005. So 1 minus 0.005 is 0.995. So then we will use inverse normal 0.995. So in our calculator, we use inverse distribution, select the third option, inverse normal, and then type in 0.995. And the answer is 2.58. This is our Z value corresponding to the confidence level of 99%. Now let's try our third example. A random sample of n equals 50 observations is selected from a quantitative population, produced a mean of 30.6 and standard deviation of 12. Question A. With 95% confidence level, what is the margin of error when estimating the true population mean? Question B. What is the lower bound and upper bound of the 95% confidence interval for the true population mean? For question A, we are going to calculate the margin of error when estimating the true population mean. And our formula for the margin of error is ME is equal to Z times SE. SE stands for the standard error. And our SE is equal to the population standard deviation, sigma, divided by the square root of n. But because we don't have the standard deviation of the population, our best estimate of the standard deviation of the population is the sample standard deviation S, and this is the value that is given in this problem. S is equal to 12. So our standard error is 12 over square root of 50, and this gives us 1.6971. Now let's calculate the Z value. For the Z value, our formula is Z equals inverse normal of 1 minus alpha over 2. Our alpha is equal to 1 minus the confidence level or confidence coefficient. And because our confidence level is 95%, so alpha will be 1 minus 0.95. So alpha is equal to 0.05. So we substitute this value in this formula. Alpha is equal to 0.05 and divide it by 2. That will give us 0.025, and subtract that value from 1. The result is 0.975. So our Z will be inverse normal of 0.975. Inverse normal, so secant function distribution, third option, and then type in 0.975, and our Z value is 1.96. So now that we have the SE 1.6971 and we have the Z value 1.96, we can now calculate the margin of error ME. By substitution, our Z is 1.96, our SE is 1.6971. So multiplying these two numbers, that will give us 3.3263. So therefore, our margin of error, ME, is equal to 3.3263. Now for the 95% confidence interval, we are going to calculate X bar plus minus ME. And our X bar is given to be 30.6. And our ME, we just calculated this. This is equal to 3.3263. So what we have is 30.6 plus minus 3.3263. For the number on the left side, we use the minus sign. So 30.6 minus 3.3263, the result is 27.2737. This number is the lower bound. Now for the number on the right side, we use the plus sign. So 30.6 plus 3.3263, and the result is 33.9263. This number is called the upper bound. We call this interval the 95% confidence interval when estimating the true population mean. Let's try our next example. A dietitian selected a random sample of n equals 50 male adults and found that their average daily intake of dairy products was 756 grams per day, with a standard deviation of S equals 35 grams per day. What is the lower bound of the 95% confidence interval when estimating the true average daily intake of dairy products for male adults? Now, to determine the lower bound of the 95% confidence interval, we need to determine the confidence interval using this formula, X bar plus minus ME. Now, our ME is equal to Z times SE, and our SE is equal to sigma over square root of n, where sigma is the standard deviation of the population. But because we don't know the standard deviation of the population, then we will estimate that standard deviation of the population using the standard deviation of the sample, which is 35. So our SE is equal to S, the standard deviation of the sample, over square root of n, and our S is 35, our n is 50. So 35 divided by square root of 50 will give us 4.9497. So this is our SE, the standard error of the sampling distribution of the sample mean. Now for our Z value, this is equal to 1.96. And if you are not sure how we come up with this value, you can go back and watch example number 3, the previous example. That's the same Z value under the confidence level of 95%. So now that we have the Z value and we have the SE, we can substitute that here and calculate for the ME. So our ME is equal to 1.96 times 4.9497, and this gives us 9.7014. So this is the value of the ME. Now that we have the margin of error, ME, we can substitute that value to the confidence interval, which is x bar plus minus ME. Our x bar is the average of the sample, which is 756. So we have 756 plus minus 9.7014, the value of ME. And the first value on the left side, the lower boundary or the lower bound, we use the minus sign. So 756 minus 9.7014, that will give us 746.2986. And then the value on the right side, we call this the upper bound. We are going to use the plus sign. So 756 plus 9.7014, this will give us 765.7014. So this interval, we call this the 95% confidence interval of the population mean. So what is the lower bound? The answer is 746.2986. By the way, if the question is asking for the upper bound, then the answer will be 765.7014. Okay, that's all for today. Until next time, thank you for watching.